So yesterday you talked about linear inequalities or learned about them, and today we are going to learn about systems of linear inequalities, which means instead of one equation or one inequality, you will have two inequalities. So the first thing we're going to be doing is identifying solutions of systems of linear inequalities. So they give you the problem 2, 1, and the system y is less than negative x plus 4, and y is less than or equal to x plus 1. Same thing as 5, 1 when we were solving systems of linear equations. You take this point and you have to plug those coordinates into the first and into the second, solve the left and right hand side independently of each other, and hope you get a good answer. And if you do get a good answer, meaning it's true, it is a solution. If you do not get a good answer, meaning it's false, it's not a solution. So let's look at this 2, 1, and in for y, we're going to look at this first equation right here, and we're going to write that out. And in for y, we're going to put 1 is less than negative 2 plus 4, and we get y is less than 2, and that checks out because 1 is less than 2. And now we're going to use the second inequality, and in for y, we're going to put 1 is less than or equal to 2 plus 1, and we get 1 is less than or equal to 3, and that is also true. So 2, 1 is a solution. Okay, second problem we're going to do gives the following information. It gives us the point of 2, 0. So if you graph these two inequalities, they would intersect. Y is greater than or equal to 2x, and y is less than x plus 1. So we are going to take the first equation. Y is greater than or equal to 2x, and for y we're going to put 0 is greater than or equal to 2 times 2, and we get 0 is greater than or equal to 4. That does not check out, so we automatically know it's not a solution. Normally in your homework you could stop and say no, it's not a solution, but for the time being we are going to do this next one just because I can. And this one says 0 is greater or less than 3, which checks out, but since one of them doesn't check out, it's not a solution. So let's go to the next example. And in this next example, we're going to be graphing some linear inequalities, and we're going to give two ordered pairs that are solutions and two that are not solutions. So the equation, or I keep saying equations, the inequalities they give us are 8x plus 4y is less than or equal to 12. And the second one is y is greater than 1/2 x minus 2. And just like yesterday in the little tip I gave you, you need to have both equations with y on the left side by themselves. The second one down here has that done for you. So we're going to take 8x plus 4y is less than or equal to 12. We're going to subtract 8x from both sides, and we're still going to write it in the y equals mx plus b form. So when I rewrite the 8x on the right side, I'm going to put that first, and plus 12. Then I need to divide every single term by 4, and I get y is less than or equal to negative 2x plus 3. So now instead of using this equation is now turned into that equation, which I can use to solve. So we go through, and we're going to start graphing. We're going to start graphing this one first. It'll be the red line. It has a less than or equal to sign, so it's going to be a solid line. We're going to mark plus 3 on the y-axis since that's the y-intercept. And then our slope is negative 2 over 1, so we go down 2 over 1, and down 2 over 1, down 2 over 1, or we can go the opposite way and go up 2 over 1, up 2 over 1, up 2 over 1, and we need a solid line. All right, the next one I'm going to do in yellow. I'm going to do y is greater than 1/2 x minus 2. It's just a greater than sign, so we're going to use a dashed line. Our y-intercept is negative 2, and our slope is 1/2, so we're going to go up 1 over 2, up 1 over 2, up 1 over 2, and we can go down 1 over 2, down 1 over 2, and we could keep going for a really long time if we wanted to, but I'm going to stop there because it's Saturday night and I don't want to keep going. So, our graph should look something like this at this point. Now, we need to shade. So, how we're going to do that? Let's look at the red line first. The red line says less than. So, we are going to shade everything that's less than or underneath. All right? And then the yellow line says greater than. I'm having a hard time talking. So we're going to shade everything that's above. All right? And then we're going to get our solutions from where we have intersected our shading. So we can choose, now we have to choose 2 solutions and 2 no solutions. All right? So our solutions come from any points that are in the region that we shaded with both red and yellow. It doesn't really matter what you pick. So we could pick this point, and we could pick this point. So the first point is negative 8, 6. And the second black point on there is negative 2, 3. Okay? And an easy way to pick your no solutions are any points that are in just yellow or red. So let's choose one from the yellow. We'll choose this point. And one from the red. We'll choose this point. And our yellow point was 7, 3. And our red point was 2, negative 4. And then you could go ahead and check all 4 of those points in your original 2 inequalities if you really felt the need to do so. So that's how you do those. You graph each inequality. You shade it according to how you were taught to shade it yesterday in the video. And then where your shading overlaps, that's where you get your solutions from. And where your shading doesn't overlap, that's where you get your no solutions from. Our next set of inequalities is the following. We get y is less than 2x minus 3, and y is greater than 2x plus 2. And with these problems, they tell us to graph each system, like we just did before, and then describe the solutions. So they already both have y on the left-hand side by themselves, so we don't have to do that first step of getting y by itself. So I'm going to do the first in red. Negative 3 is our y-intercept. And then we go up 2 over 1, up 2 over 1, up 2 over 1, or down 2 over 1, down 2 over 1. And since it's just a less than, we're going to have a dashed line, which means it does not include those points on the line. And then I'm going to do the other line in yellow, and we have a positive 2 y-intercept. And then we have up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, and that is a bold line, or a dashed line as well, I'm sorry, because it's just a greater than. And if you remember from 5-4, if you have the same slope and different y-intercepts, you are going to have parallel lines. So you could have already seen that you are going to have parallel lines. Now we have to shade those. So we'll shade the red first. It's a less than. So we shade below the line. Okay. And then the yellow is greater than, so we shade above the line. And you will see that you do not have any overlapping, so there is no solution. There's only solutions if you're overlapping. Okay, the next set of inequalities you will have is y is greater than x minus 3 and y is less than or equal to x plus 1. Again, this one already have y by itself, so you don't need to do that extra step. We're going to do this first in red. So we get -3, y-intercept, up 1 over 1, up 1 over 1, up 1 over 1, or down 1 over 1, down 1 over 1, down 1 over 1. Okay, and since it's just a greater than sign, we're going to have a dashed line here, which means it does not include the points on that line. And we're going to do the next one in yellow. We start with +1, and then we have up 1 over 1, up 1 over 1, up 1 over 1. And you should have been able to tell they have the same slope, so they will run parallel to each other. That is less than or equal to, so it's going to be a just normal straight line, no dashes, which means it does include the solutions on that line. Now we're going to go ahead and we're going to shade. So y is greater than, so we're going to shade above the red line. Hopefully, it's all of a sudden, oh, there we go. And yellow is less than, so we're going to shade below. Okay, so the solutions that we have are all in between these parallel lines. Okay, those parallel lines kept going up. So, solutions are all the points between the parallel lines. That's the symbol for parallel because I don't feel like writing it out. Okay, one more. Here we go. We have y is less than or equal to -3x minus 2. And we have y is less than or equal to -3x plus 4. Again, you should know automatically those are going to be parallel because they have the same slope. So again, we're going to do that first inequality in red, -2, and then we go down 3 over 1, down 3 over 1, down 3 over 1. We can go up 3 over 1 as well. And that is a less than or equal to, so it's just going to be a bold straight line, just like normal, which means it includes the solutions on the line. And then we're going to do the second one in yellow like we've been doing, +4. We go up 3 over 1, up 3 over 1, or we can go down 3 over 1, 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 and that one is going to be a bold straight line as well, no dashes. Okay, so now we're going to go ahead and do our shading. Y is less than or equal to, so we are going to shade all of that. And the yellow, the y is less than or equal to 3x plus 4, is also below. So we're going to go ahead and we're going to shade all of that. So because all of the shading that overlaps is below one line, there's no special, it's not like part of below one line and then below another line, because I think up here, I'm not going to show you, well yeah, I'll show you. See up here, it was like, on this one, it was below and it was above the other line. It was below the red, above the yellow. So, this one, however, is just, the solutions are just below the red line. So the answer is the inequality of the red line. So all your solutions are here, where y is less than or equal to negative 3x minus 2. That's where all your solutions will run. I'm sorry this video is long. I think we're done with the lesson now, hopefully. So you can get started on your homework assignment.